In today's short video, I'm going to show you how to take a temperature sensor value, and you can use other sensors later on as well, put that data on the cloud, and then you will be able to, with your cell phone, access that data and graphs from anywhere in the world. This is easier than you think. Let me show you how. So let's have a look at our system block diagram. First we'll have our Arduino Uno, and coupled to our Arduino will be a temperature sensor. This is a 10K thermistor, the same one that we've used in our previous video. Later on we will also add a pH sensor, EC sensors, and a lot of other sensors, as well as also add control to the system. But in today's video we're going to focus on our internet or our cloud connection. So our temperature sensor will be, this temperature will be sensed and it will be passed to our Arduino Uno, and the Arduino Uno will communicate that via the Wi-Fi module, the ESP8266 Wi-Fi module, to a cloud service called ThingSpeak. ThingSpeak is of course a free cloud service that you can use, and we'll talk about that a little bit later on. Then you will be able to either access the data on your cell phone or then via your PC. So let's have a look at our different components. The first, here's our electrolytic capacitor. Please note that there's a negative side and a positive side for the electrolytic capacitor. Then we've got our ESP8266, and we've also got a little bracket for it to be able to fit on the breadboard, because the ESP will not be able to fit on the breadboard as it is. Right, so you just push it into this little socket, and there you have it. So please get yourself this this little board as well, where the ESP chip fits in, so that you can mount it on your breadboard easily. Then we've got our 10K resistor. Now our 10K resistor, brown, black, orange. So the brown is 1, the black is 0, and the orange is 3. And the orange, the last color there, means the amount of zeros. So it's 1, 0, and 3 zeros. That will give you 10K. Then also get yourself some of these connection wires. They really make it much easier for you to work with. We normally use the male to male. You also get a male to female and a female to female that you can use from time to time, but mostly we will use male to male for the breadboarding. And then we've got our thermistor. Our thermistor is a 10K thermistor, and there's no polarity here, so the two wires, it doesn't matter which side you put in, which side of the circuit. And then of course get yourself a small little breadboard. So the breadboard makes it much easier for you to build your circuit. Now please note, it's got 2 middle sections and then 2 side sections. The side sections are connected, say, from there till there, and another line from there until there, and the same on that side. So the connections underneath the board is like that, and then in the middle here, these 5 are connected, 5 are connected like that, and there's a break in the middle here, and on this side also 5 connected. So that's the way that the breadboard is connected underneath it. So definitely get yourself a breadboard. And then of course we've got our Arduino Uno. Now you can see here, this is just mounted on a piece of plastic. You can use Perspex or anything to mount it. I've just bought this with the Arduino, so that it's very easy to work with. So now the breadboard and the Arduino are fixed together and it's easy to do your build. Here you can see the circuit diagram of our project, and let's have a quick look at the connections. Here's our Arduino Uno, and here's our ESP module, and also the connector where we connect it to so that our coupling to the breadboard is easier. Then we've got our 10K thermistor, we've got our 10K resistor, and we've got 1000 microfarad capacitor. Let's start at the right hand side here with the 1000 microfarad capacitor. First, the negative part, you'll see there's a negative line on the capacitor there that's indicated your negative, and that's connected to your ground of your system. The ground of the system, as you can see here, is connected to this bottom rail of the breadboard, and all our grounds will be common in this case. So it's also connected there, and then of course there to our bottom part of our resistor. The other leg of the electrolytic capacitor is coupled to the VCC of the ESP module. So it's very important that this capacitor is here, because it will basically act as a small storage of energy, so that our power supply will not be influenced by the short bursts of transmitting power from the Wi-Fi module. So our next set of components is our resistor. Our resistor, 10K resistor, the one part is connected to ground, the one leg. The other leg is connected to the 10K thermistor, and the other side of the 10K thermistor is connected to 5 volt VCC. Again, this top rail of our breadboard is 5 volt, and you can see that it's connected to 5 volt here on the Arduino. The middle pin where the resistor and the thermistor connects is coupled to A1, the same as our previous project. The next part is our ESP module. Now, ESP module, the ground, of course, is connected to ground. The VCC, very important, of our ESP module is 3.3 volts. So this orange wire is connected to the 3.3 volt of our Arduino Uno. Then also connected to that 3.3 volt, you can see here it's a bridge between reset and VCC. There's it. And you can see there's also a bridge between CHPD and VCC. So we're connecting it there so that all three of these legs are basically connected to 3.3 volt. Then our TX of our ESP chip is connected to the RX of the Arduino board, and that's pin number 0. And then the TX of the Arduino board is connected to the RX of our ESP module. And the connections, like you can see them there, are very simple to do. So if you go back to this part of the video, when you do your connections, you can make sure that your connections is correct the first time. I may just bring your attention again to the fact that the VCC of the ESP module is connected to 3.3 volt and not to 5 volt. So let's start with the build. So we can just make sure our ESP module is the correct way around, fitted into our little extension socket. So we can just push that into our breadboard like that. Maybe I'll shift it just a little bit so that there's it. Alright. Then let's start with our electrolytic capacitor. And remember, negative on this side and positive on that side. And we mount this as close as possible to our ESP chip, with positive to the VCC of the ESP, and then the negative to the ground on the other side of the ESP. And you can just push it down like that. Just make sure that you don't touch the other legs on this side. Now if you look at your circuit, you will also see that the reset pin and the CHPD pin are connected. So I'm just going to put a jumper in there, and they're also connected to VCC. So you can just put a small jumper in there. You can use a wire, but I'm just trying to so that there's not too many wires in the for the camera here. So I've got two jumpers. So I'm basically connecting now VCC to reset and to CHPD. Alright, so all of those three are connected now like that. So that's finished. The next thing is your TX of your ESP module will go to the RX of the Arduino. The RX is on pin number 0, and then the RX of the Arduino or the RX of the ESP chip will go to the TX of the Arduino. So there's that connected. Let's start with our 10K resistor. Now our 10K resistor is going from a specific point there to ground, and let's make our ground this side here on this rail. Immediately let's couple the ground, so we can just push into that rail which is connected to ground on your Arduino. So it's connected there. Then our thermistor, remember no polarity here, so we'll go from that 10K resistor, so we'll just push the one leg in there. Is it? To VCC, and let's make our 5 volt VCC here on this side. So our 5 volt VCC connected from there to 5 volt on the Arduino. Make sure you're on the 5 volt pin, not the 3.3 volt pin. Alright, so you can just push that in. And then we must still couple the VCC and ground of the ESP chip to the Arduino. Now the ESP chip is working on 3.3 volts. So this wire that I put there on the VCC of the ESP chip must go to 3.3 volt on your Arduino, and you'll see that's just next to the 5 volt there. The ground of your ESP must go to the ground, your common ground, which is the same ground as that we've got here. So all the grounds on this system is common. And then we need to couple the center point between the resistor and our thermistor to A1, and you will see that's exactly the same as our previous project. Alright, so there you've got it. The complete build, very easy and simple, as long as you use your circuit that I've given you and also the instructions at the start of your Arduino program, then you should not have a problem at all to build this. So let's talk about ThingSpeak. ThingSpeak is a free cloud service that you can use, and when you go to the page the first time, you can just register. I'll put a link for you in the description of the video. So I've already registered, so let's go to my account. So let's go to my channels. On a free account, you've got, I think, 4 different channels available for you. So let's have a look at one of them that we're going to use in this project. Here you can see I've already got one field defined in this channel, and we're going to see our temperature lock here on this field. Your channel settings, if you go to channel settings, you can give the channel a name, and you can also then just name your first field. Now our first field, we're going to lock temperature in. Later on we will have a field for pH, EC, maybe for light intensity, and a few other things, humidity and a few other sensors. So for this video, we're only going to log temperature to the cloud. So we just write in the name of the field and we tick the box next to it. There's a few other things here, but not important for this video. So you just save your channel, and then very important, you go to your API keys and you will see there's a write API key. This key you will need in your software of your Arduino program. Very easy, you just copy it here and you paste it into the Arduino program, and we'll get to that just now. So we've opened our Arduino IDE. In the previous video I've explained how to download it. It's also free. So after you open it, you will take in the first comment below the video, I will put the code in for you. So you just copy this code and you paste it into this Arduino IDE of yours. There's a few things here that I want to bring your attention to. The first is, if you've got 2 forward slashes like this, it means that the rest of that line is commented out. So this first part up until there is not part of the program itself, but it's just comments that I've put there to help you. And you can see I've said there that the 1000 microfarad must be connected between 3.3 volt and ground of the ESP8266. And then I've got a few connections just to tell you to make sure that your connections are correctly done on your system. The next thing is your Wi-Fi name and your Wi-Fi password. Those things must be filled in, so you change this part here from there till there with your Wi-Fi name, and from there until there with your Wi-Fi password. The next thing is the IP address of ThingSpeak. You leave this just as it is, it will stay the same. And then very important, remember we've talked about the key, the right key. So let's go back to ThingSpeak, and you will again find under your API keys your right key, and you just copy this key, copy it, and you take it then to your Arduino program and you put it in there from there till there, and you can just paste it. And that key must be the same as the key for that channel of yours. This is very important. So this 1, 2, 3 parts in the program you must set yourself. The next line is then your time interval in seconds between your samples. So this you will do in seconds, maybe for 10 minutes or 20 minutes. I don't know how long you want to wait between your samples. I do suggest that you don't leave it as small as this. I've got it as 3 seconds just for testing this program, but make this, I would say, at least 10 minutes between your samples where the data is then written to ThingSpeak. The rest of the code, I'm not going into detail. I can just show you the main loop here. The main loop will call 2 functions. The first function is get the temperature. The get temperature function will then just get the temperature from the sensor. I'm not going into detail now. We will slowly start to go into detail into the software later on, so that you can, in later videos, so that you can get familiar with that. And then I call a second function that will do the transmission of the Wi-Fi, and then I will just delay it for the amount of seconds that you've stated earlier in your software. Further on with the code, you don't need to know anything at this stage. It's very simple code that I've written for you, and later on we will discuss this code. As we move on step by step, we'll do as more and more, and you will get more familiar with the coding itself. So at this stage, after you've set those few parameters, you're going to compile your sketch and see if it's compiling correctly. So it's done compiling, and now we want to upload it to our Arduino board. So we can now plug it into our Arduino board, our cable from our computer. We will then go to our tools and we will select the correct port. It's port 12 in my case. You will see Arduino next to the port. And very important also, just make sure so that your board is with the Arduino Uno board. Those two things are very important. So after it compiled correctly, you can upload it to the board. But before you hit this upload button, you just make sure you take these wires on the TX and RX of your Arduino board and you just lift them out, and then you hit that button and it will then upload the program to your Arduino board, and you can see it's done uploading. Then you can put those wires back. The reason why you must do that is because the communication on this cable also happens on those wires. And if you leave these wires in, then it will not program correctly. So please remember that. As soon as the sketch is uploaded to the Arduino board, it will start logging the temperatures, and you will see the logs as they come into ThingSpeak. There you could see the last one. I'm now going to just with my hand touch the sensor, and the temperature should rise from that. So we'll just keep an eye on the temperature. From the next reading it would start to rise as the sensor heats up. And there you can see it's rising the temperature, and you can see the lock working. You can now go to the App Store on your phone, and you can just type in ThingSpeak, and you can do a search, ThingSpeak, and you can do a search, and you'll find that there's quite a few apps where you will be able to connect with ThingSpeak. Now there's one Things Viewer, this one that we're going to use in this video, but you can use some of the others as well. You will see there's some nice gauges, and there's really a lot of apps that you can use with ThingSpeak. So now you can select Things Viewer and install it. I've got it already installed, so we'll just go to it. You can then open the app, and I've got already my channels on there, so I'm just going to delete them to show you how to put yours on. So you will just select New Channel, and then you need a channel ID. So if you go to your channels on ThingSpeak, you can just go to Channel Settings, and you will find your channel ID there. So the channel ID in this case is 43224. 432244, and I will say save, and you will see immediately my channel will appear there, and I can just then hit the channel, and the fields of the channel will be displayed, or the different fields that's available, and I can just hit the temperature, and there you can see the temperature reading on your phone. You will see that it's exactly the same. You can see there I've touched the sensor, and now it's dropping down again because I've removed my hand. Thank you for watching this video. Please remember to subscribe and like the video, and I will see you in the next video. Thank you and bye-bye.